think it's recording. Yes. So these are the videos that are very, very important. Okay, and I'm going to record the leftover questions on function growth and induction, mathematical induction today. Only 2 of you out of the 50 I have in total have emailed me questions. I am not happy. Nobody emails me anything anymore. Okay, except Nick. And but at least email me questions, right? So I'll post one more video here. So they're all taken from the Math 243 website. Oh, I wanted to show you this. These are the PDFs that I talk about, my lecture notes, these PDFs, that's it. That's all you need. And my review videos, okay? That's all you should be studying from. So I've picked the few that the students asked me and a few more for practice, okay? Question number 7 from the function growth part. So what is happening here? I have to write the following functions in increasing order from the smallest to the largest order. Smallest means, so I have to go like this. Smallest, then, keeps growing. Okay, that's how you think about it in exam. So let's call these functions some names so that it's easier to check. I have this function. Simply, it's always recommended if you see crazy functions like this, you try to simplify it, okay? This is number 1, this is number 2, this is number 3, this is number 4, number 5, oh God, there are too many here. 6, 7, 8, this is number 9. Okay, I have 9 functions. It's of course is there so that you practice. Okay, let's simplify first. Whatever we can cancel, remove the extra constants, multiplier, constants, add it to a function. If log is raised to some power, bring the power to the front because it's really no use to us, right? Log raised to any power is still slower than the linear function, right? You could have log raised to power 100. It would still be slower than x, okay? This is very important when you go to computer science courses. Your future, you will be doing this routinely. It's going to be used every day. It's going to be a part of your life. So it's important we understand this. I have done so many reviews on function growth, but let's do this question. So let's simplify first. That should be the first step. I'm going to write this as 7n log n, right? 7 is pretty useless. It's just a multiple. It has no impact if n grows very big, right? So you can remove 7. Do this. Try to remove the frills. It becomes more clear in exam. Number 2. How do I simplify number 2? Turn it to x squared. I like that. Yeah, right? Remove the, well, first thing you want to do is remove the non-dominant terms, which is the constant. We don't care about the constant, right? The linear is pretty irrelevant because it's in plus. So the dominant term is n5, and the dominant term in the denominator is n cube. I have examples solving this in my lecture notes, okay? I can simplify it further. This is basically n squared. You see, it looks scary, but when you remove the frills, it becomes a very simple quadratic function. Any questions? Everybody can do this? If there is a plus minus going on, remove the non-dominant terms, okay? But not if there is a multiple. You see, n log n is multiplied. It's different. If there was n plus log n, then I would get rid of this. Irrelevant, okay? Yes.
Would n log n be faster than just n?
Yes, that's correct. Because yeah, it changes things, right, when it's multiple. So okay, good question. Number 3, how do I simplify number 3? Well, I cannot do it any simplified. It's already pretty straightforward. It's of course going to be slower than n log n. For number 4, no need to simplify. Number 4 is still cannot get any easier than this. right? Is an exponential function, base is 2. Number 5, how do I simplify number 5? What is number 5? It is just n log, but what is log 5? It's a constant. Every time you see a constant, you get rid of it, right? Number 5 is just a linear function. Number 6. Number 6, you can't simplify any further, right? It's a polynomial times a log, it stays that way. Number 7, it's just n cube, right? When n cube gets way bigger, you see there are big numbers there to just throw you off. So if you see a constant, get rid of it. Okay. What about this one? Number 8 is just a square root. Question?
Number 7, why wouldn't you also do the log? Because that would still grow faster than just a normal.
No, that's number 6.
Oh, well.
Number 7 is just n cube. Yeah. Be very careful, okay? What about number 9? Now, this is a trick question and it's very important. We are solving questions from the 243 website, okay? Continuing the review. Number 9, I cannot emphasize on how important this question is and how many times you will make a mistake in exam. So be very careful when you see this question. If I give you n plus 1, suppose I give you, same thing. If I give you 1.9999 n plus 1, and you would think that, oh, this power is greater than this power, right? So this must be faster. Very common mistake. You have no idea how many times I've seen this. Exactly. But we ignore it in a different way, okay? We have to do a little bit of simplification, but we will ignore it. But you see how we can simplify this? This is nothing. Well, you should know it by now because I've been doing this a lot. This is nothing but this, right? Now, what is this guy? Constant, doesn't really matter. I know I'm not copying all the 9s here. It really doesn't matter how many 9s are there. There could be 100 9s. It will still grow slower than 2n. Okay? So don't get thrown off by some crazy power here. Okay? Now, things will change if you had a question like this. Now, it's not involved here, but if I gave you a question like this, say 2 to the power 2n plus 1. Now that changes things, okay? That's why it's important. This means this is 2 square to the power n times this. It's still gonna be bigger than 2n. So you see, it's very subtle, but if the n is multiplied, if the n is multiplied by a constant, it changes things. But if the n is by itself and the number is smaller, you see why it works, right? Okay, now who's going to tell me? I have simplified all functions as simple as they could be. This is number 1, number 2. I know there's too much to check. What is the smallest function of all of these? Square root of n is, yeah, that's the smallest, right? How many agree with that? Good job. So what is the number of that square root of n? This was number 8. We have to be careful. We have to track things. Stay organized, okay, in exam. What is bigger than square root n? How many agree with Daniel? Anything else? Do you have another candidate? Any other candidate you would like to put there? No, right? We're looking at all of them, and it makes sense that square root of n log n, which number was it? Number 3. Okay, after that. I mean, you will copy the exact function which is there in the question. We are just using the simplified versions, right? 5 or 1. What is 1?
1 is n log n.
No, definitely 5 grows slower than that. Square root of n log n is the smallest. Okay. Then we have, what was 3?
The smallest one is just a square root. It's just a square root.
Yeah, so 8 and 3, and then we go 5, because if you multiply by log n is a positive quantity greater than 1, it's gonna grow faster than just n, right? If I draw the graph, now these are there to trick you. So n is gonna be here, n log n, slightly higher, and then square root n log n is gonna be lower than that. You can check the limit. Try the limit test, okay? I won't give you this close calls in the exam. I know it's tricky, but in exam it will be very straightforward, like 1.99 or 2n, right? It's a very clear call, which is gonna be higher. Make sense? Now, let's complete this question. Let's say we go with 5 next. We go with 5 because we know for sure that this function 1, which is n log n, is gonna grow faster than 5. Okay, what's gonna grow faster than n log n? Is there an n square here?
Yeah, it's.
Did we forget the n? Oh, we just, don't forget anything. It's a tough question, but it's good practice, right? Any questions? Okay, what about faster than n square? Number 7. What about faster than n cube? N cube times a positive quantity, right? Log 10,000 grows faster than just n cube, right? I mean, n cube times log n will always be faster than n cube. After that, how many go with number 9? Good job. After that, now, of course, you see this question is crazy. It's too many functions, but it serves the purpose of how we are supposed to handle these questions, okay? You won't have these many functions, but you won't have these many very close functions also, but you should know the basic fundamental rules, okay? On how to check. Try to remove all constants and then check. Good? And don't trust my answers here. Maybe double check with the Math 243 website if I made a mistake. Now, let's do this one. Number 8 is using the limit of the quotient of f and g to decide if f is big O of gx. Now, this is like a true false type thing. If it's big O, then it's true. If you get a question like that, okay? What should the limit be? What is the limit definition? Limit x approaching to infinity, f of f divided by g. What should be here? So that I can say that f is big O of g. What should be this number? No. No. I did this in the review. 0. It cannot be a constant. Constant means f is order of g. Right? It cannot be infinity. That means omega. Make sense? It has to be 0. So you need to know what you are looking for in the exam. Now look at this one. Polynomials are weird. Polynomials behave differently. They are order and big O at the same time, right? If you see a polynomial of same power, you can ignore this limit definition. But let's look at a question which is not a limit polynomial, like this one. I have f of x is log x. Well, this is also a weird question. Do I have a normal question here or no? There are different bases. Yeah, check the limit, okay? What is the limit of x approaching to infinity log x over ln x? Calculus. check that. I would convert both to base 10 or both to base e and see the limit. If it's 0, then yes. If it's not 0, then no. Check it, okay? I'll leave that as a quiz for you. Yes.
It's also below, it's not 0, but like 1 or something, right? It's like finite.
No, it only happens in that case when it's a polynomial, right? It has to be less than 1. You will get a geometric series at the end, and this constant, x times something, it should be less than 1 always. So the limit has to be 0. Okay? Otherwise, it won't work. I was looking for a good example. This one. Let's check this. We know that 2.0001 is gonna be faster than 2 to the power x, right? But if I ask you to apply the limit definition, you just have to show this. Limit x approaching to infinity, f of x, which is 2x. I'm solving part f. All solutions are there on the website. So you can take a look there also. 0.0001 to the power x, right? What happens here? Can I write it like this? 2.0001 to the power x, limit x approaching to infinity. Is this less than 1? So this will be, is this less than 1? Have it, use calculus here. If this ratio is less than 1 and you raise the power to infinity, this limit is going to be, just remember this, okay? You don't have to do any calculus in this course. But remember this thing, this is the most important thing. Show this. So by limit definition, 2x is big O, 2.0001. Okay? Just I want you to be aware of, if I asked you the limit definition, just be able to show this.
Was it when it's like finite, something other than 0?
It's order, is theta. If it's a number, then it's theta. Okay? Yes. When then it's ordered, like the polynomial functions. Polynomials are just, weird. Polynomials don't waste a second on the question. They are always order big O, omega, same thing. Okay? For part A, the limit will be 0. So by limit definition, it will be a big O. Okay? But it's order also, right? So polynomials are weird. Those I would just not even think about it. Okay? I would not give you a limit definition for polynomials. I have more examples here. Look at this one question. Yeah, you get it.
Yeah, it should be ordered.
Just theta.
I know it's what is happening in the solutions. What did I write in the solution? Can somebody check? Did I say big O? Because for polynomial it's big O. But in this case it's not. Check that in the solution. I mean, I can just remove this. It doesn't really matter, right? It doesn't depend on x. It will be a constant, right? So it's not big O based on this definition. Let's see what I'm saying here. Is this function? Which question was that? So it's constant f of x is, yeah. So for polynomial, we just, we ignore this rule that it has to be 0. So if the number is 0 or a constant, you can say that it's a big O. I mean, read these solutions, okay? Now this is a good question. even if I multiply an exponential by a polynomial, it doesn't really matter. The bigger base is going to be the big O. Okay, it could be x cube here. Right? It's O is order, polynomials is just weird. Okay, and this question is where I want you to bring, you have your attention here. If I multiply a base to the power x exponential by a polynomial, doesn't matter. The bigger base is always going to be the big O. Okay, now that we have that out of the way, I thought I had more questions. This is the question I gave you in the quiz, right? It's from my lecture notes. Try 2 minutes, solve it. Very important question, especially for like a true false thing. Is this big O? If exactly, I'm asking for first one. Okay, is fx big O of x squared? True or false? Right? How many agree with true? Exactly, that's what you're supposed to do, right? What about part B? But if I ask you this question, is true or false? Agree? Can everybody do this? Are we understanding the concept of big O, big omega? No, x4.
Oh, are we comparing this?
Yeah, we're comparing x squared with part B. It's not big O, right? Yes, Bethlehem. You are allowed a calculator. Yes, you are. But you must show work. If I ask a limit definition, I need the correct limit setup. Yes. It is x squared. It will grow with this thing, right? The floor, remember I did this in the lecture notes, it's less than something x times x plus 1 and greater than x times x minus 1. It grows, it's big O, big omega, theta, everything. Okay? It's theta and big O. It's everything. It's order theta, order x squared. This was done in my lecture notes. So I want you to read through this. This is important question, okay? Polynomial, it's big O, big omega, theta, everything. Right? We will not waste any second on here. Is x log x for part D, focus on part D, is x log x big O of x squared? True or false? Okay, you have to double check, okay? Every time you think of true or false questions like this, draw the diagram, check the limit, be able to double check your answers, okay? Or are we comfortable with this? Okay.
A symbol called next to below, I hope.
Which one? Omega, right? And this is theta. Okay. Yes, Ramzi. C and no, not D, C and E. Yeah, yes. Yes, good job. If you get a question like this, it's basically x squared. Grows at the same rate. Okay, question? Yes.
Theta then automatically implies O and omega, right?
Yeah.
So can you just write theta down and that's fine?
You will probably get an MCQ or true false on this. Okay, so you have to pick the correct answer based on that. Okay, I just want to make sure we understand this concept is down with all of you. It's important. And I will not do a review when final exam comes. This will be a heavy part of the final exam too. That's why I'm spending so much time on this. Okay. Alrighty, now the last thing that I want to talk about is induction. I think if we practice these proofs and the proofs from my lecture notes and a bunch of them, write proofs down. Do not read through them. Do not read proofs. If you make a mistake in exam, I will not be happy. Do not read proofs. Write them down, write proofs on a paper, check your answers with the answers provided in the lecture notes or the PDFs online, and find your mistake. Because a big part of the question is find a mistake in this induction proof. So you should be able to find a mistake. And you can only find your mistakes if you write your own proofs. Then you know, then you remember that, oh, I don't have to make this mistake again. Okay? You will not learn your mistakes if you just read through it. Reading through induction seems like, yes, it's very easy concept. I understand everything. I can do it. But when you write your proofs, that's the time when you learn. Okay? Alrighty. Let's talk about this question. Number 3. I have to prove using induction that summation this blah blah is equal to this for all positive integers n. What is the first thing I do? No. You've forgotten already. Sarah. Good job. And call it Tn, right? See, write your own proofs. Summation k equals n, and especially for the free response part, when I want you to write a proof. This is what I want. Writing the equation again. Then you do base case. Base case, right? I highly recommend you make a skeleton. Skeleton means just write down all important components of a good proof, which is base case. And what's the next step? Inductive step, right? And what's the next step? Conclusion, or that closing statement, which starts by principle of mathematical induction. Leave like enough space. Bring a pencil for the exam. Okay, so you can erase things and don't have to cancel. Yes.
It's funny if we just how we did it in the assignment for this topic.
Which assignment are we talking about here?
Written.
Written homework. Oh, I don't check those. But did you get a good grade? Then you're fine. Yes. Okay. But just write like this, exactly what I'm doing right here. Okay, what is the base case? Now this is another important thing. Where should I start? Yes, for all n greater than or equal to 1, because it's positive integers. Is this clear to everyone? Base case matters where to start. If it's 3, you start at 3. If it's 7, you start at 7. If it's all positive integers, you start at 1. 0 is not positive, okay? Alrighty, so I prove P for n equals 1. For n equals 1, you do the LHS, RHS, right? The left-hand side, which is, if n is 1, there is only one term here. So it's basically 6, 1 to 1, 6k minus 1, right? 5. What is the RHS? Put 1 here. 3 times 1 square plus 2 times 1 is 5 again. So this is a good amount of work that I need on the paper, especially for free response where I want you to write a proof. Okay? I proved LHS equals RHS, base case done. Good. Everybody can do this. If you get a summation, this is all you have to do. Plug in n in that summation. Now, if it was 3, for example, I'll do that example in a minute. So what is the inductive step now? Next thing. Assume Pn is true. Are we missing any buzzwords here?
Arbitrary.
Arbitrary, yeah. See, that's my favorite word. For some arbitrary. Do not miss the favorite word, okay? Arbitrary. You know why? because we're not fixing an n here. We are saying whatever random n you pick, we are assuming is true. Okay, it matters here for proof. For some arbitrary integer n.
You don't have to like say it's positive or whatnot.
No, it's the proof only works for positive integers, right? Make sense?
Why is it that we say some?
Good question. All and arbitrary don't go hand in hand. When I'm using the word arbitrary, it means that I'm picking randomly one of you, right? If I say all random, doesn't go together. Make sense? It's a nuance of English. Okay, now what is happening here? Pn is true. I mean, I'm just going to be lazy, call it 1 here, but you know the drill, right? I have a video on induction also on YouTube for more lengthier, proper proofs. This time I have to cover more. Okay, then what's the next step? To prove Pn plus 1 is true, everybody should be able to write until here. So write down what we need to prove. Pn plus 1 means wherever you see n in the formula, replace it with n plus 1. So I'll go summation k going from 1, n plus 1, 6k minus 1 equals 3, n plus 1 plus 2n plus 1. Now this is where I see a lot of errors, which I don't want to make. You see, I have to prove this. I have to start with LHS, do some magic, and get the right-hand side. You cannot assume this in the exam. The only thing that you can assume is this guy right here, highlighted. That Pn is true, that you can assume that LHS equals RHS, not for the equation we need to prove. Is this clear? All right. Anybody, any questions? Can everybody do this in the exam? Until here at least. Then after this, the safe bet is to, I need more space, is to start with this. Consider left hand side. This is the safest bet that will remove any possibility that you would assume this is equal, right? So consider the left hand side. This will be summation k going from 1, n plus 1, 6k minus 1. I am just focused on the left hand side of what I need to prove. Now comes the math part, the most complicated part of induction proofs. Now here's something that will work all the time. If you see a summation, what you're supposed to do? Split it up. You see a summation, you break it. How do I break it? If I have n plus 1, I'm going to write it until n, copy the function, and the last term, what should be the last term? If this is the formula, and I wrote until n, what's the last term? Anybody who would like me to explain again? All okay with this? Tyson? Ian? Right? Make sense? Okay. You do 6, n plus 1 minus 1. Right? Can everybody do this? I'm breaking the summation. I did until n, and the last term, which is n plus 1, one more than n plus 1, I wrote it down. This is what you're supposed to do. You will assume Pn is true for some arbitrary integer, blah, blah, proof Pn plus 1 is true. You will write down the equation, then immediately do consider left hand side. Aaron.
Should we write the equation for Pn and that as 1?
Yeah, I'm being lazy here. I won't take off points if you just put 1 here. Yeah, okay, you don't have to copy it again. But now I'm going to use this Pn. It's equation 1. I can assume this is true. So I can use the right hand side of this equation, right? And the right hand side of this equation is 3n squared plus 2n. I'm going to replace it with. You see, this guy right here, it looks like the left-hand side. This is the left-hand side of 1. Because I know 1 is true, I assumed it. So I can replace this left-hand side with the right-hand side. And that's what we are doing here. 3n square minus 2n plus the remaining part. Okay? Good. Just follow the steps in exam, then there is very less chances that you will blank out. Write Pn plus 1, start with left-hand side, do this, and play with it, do some magic. You want to get this at the end. Okay? Or simplify that a little bit. See what is happening. This is 3n square minus 2n plus 6n plus 6 minus 5. So, minus 1. Yes, you're right. 3n square plus 4n plus 1. Right? Now, there are two ways to go about this question. You can either, yes. 3n minus 2n. Did I copy it wrong? My bad. It's plus 2n. Nick, you don't tell me anything. I'm just kidding. Good job. Somebody has to tell me my mistakes, okay? Focus, everyone. Only Nick doesn't have this job. Okay. Good. But see, now this is getting complicated. How do I get this thing? So it's a good idea to go back to the right-hand side and simplify it. Daniel? Yes.
Would it be plus 5 and not plus 1? You have 6 times 1.
Good job. Good job. Only one person in my class. Right? But Daniel, what you are saying is more difficult work, right? Manipulating this to get to this form is going to be more difficult. The easier way is to consider right-hand side. Consider right-hand side, which is right-hand side of this equation, which is 3n plus 1 squared plus 2n plus 1. And if you simplify this one, it will end up with the looking like 3n squared plus 8n plus 5. Simplify this. I just open the brackets. And you see, this looks exactly like. So we sometimes just do, just like the trick proofs, sometimes we have to solve left-hand side, simplify it until we can. Then we have to do a little bit of simplification on the right-hand side, and then they are exact match. Yes. With exponents. Which one? Actually, I have more exponents down here. You want to do this one? Use induction. Is this okay? Now there is a closing statement also. Left-hand side equals right-hand side. Therefore, by principle of mathematical induction, copy the question again, right? I have so many examples in my lecture notes where I have full solutions. I have a video on induction where I solve a few difficult questions. I have this video and there are solutions in the PDF. There is no excuse to not get these questions right, okay? I want everybody to get 10 out of 10 on this question. Don't give me a reason to take your points off. And please write something. Don't leave questions blank. Okay, now for Sarah's request, we're going to solve number 8. Use induction to prove that 6 divides 9n minus 3n for all integers n greater than or equal to 0. Now here's the thing. This is not an equation. This is not a math equation. How do I write it as a math equation? 6 divides 9n minus 3n is no use to me, right? I cannot prove it. I need a tangible We will stay away from mod here. Yeah. That's something which is more tangible, right? Mod function is J. Do not use mod function in exam, okay? You will not use mod function for these proofs. Try to get multiples, right? Easy math. We will not make our life more difficult. Number 8. So writing the induction statement, Pn is 9n minus 3n equals, because it divides, that means it's a multiple of k for some integer k. For some integer k. Is this clear? Now, this k could be whatever it feels like, okay? It could be negative, it could be positive, it could be 0. We don't care. But the n, you see, there are two different variables going on here. There is a n and there is a k. K could be whatever. N has to be greater than or equal to 0. See the difference? Everybody okay with this? Okay, now it's a very similar question like what we have always done. What is the base case? N equals 0, it tells you very clearly, right? N equals 0, so I find the left-hand side, which is 9 to the power 0 minus 3 to the power 0, which is 1 minus 1, 0. Can I write 0 as a multiple of 6? Yeah, you can, right? It's 6 times 0. So base case holds. So for n equals 0, I proved that 9 to the power 0 minus 3 to the power 0 is equal to some multiple of 6. Or 0, 6 divides 0, in other words, right? 0 is divisible by everything. If you see a 0, don't panic. This is what you're supposed to do. Good. Everybody can do this. Okay, next step. Inductive step. Sarah, make sense to you? We assume Pn is true for arbitrary integer n. Let's call this equation 1. I have to prove Pn plus 1 is true. It's very important that we know what we are trying to prove in a question. The goal should be very clear in writing and in your mind. You should be very clear what you are trying to prove. Otherwise, we'll be lost. I'll be lost reading your proof. Now, let's write it out. What the heck is Pn plus 1? This is replace n with, that is, we are trying to prove this, equals 6 times k for some integer k. This is what we are trying to prove. Now, these are those, tricky questions, the pesky questions where you have to find the trick. Last time, a bunch of you gave me good answers. So I'm relying on you. Alrighty. So I need to prove this. How do I prove this? Okay, that's the very logical step, right? Do this. If you get an equation like this, there could be a different number, 5k, 7k, doesn't matter. But this is what we're trying to prove. If you have n plus 1, which is very likely, you start with the left-hand side and break it up. Now, there are many ways to prove this. Somebody tell me. I have to use my inductive step somewhere, right? So I need to get 9n minus 3n somewhere here. Yes.
We can split it up so that we get 8 times
8.
9 plus 9. And so we're forcing the terms to show up more. So right now.
Do that. Okay. Okay, let me write down what you're saying. Okay. 8. Okay,
plus 9 to the n power. So we force the first 9 to the n power to show up, okay? We do the same thing for the 3 to the n. So we have minus 2 times 3 to the n minus 3 to the n.
oh,
And so now it popped up because you have 9 to the n and minus 3 to the n. That's p of n.
but then how do I prove this one?
And
Oh, it's still a no, it's 9 to the n. See, we came up with one solution by Daniel. I probably have a solution on the PDF if you want to read through it. You probably will come up with a solution, right? So Daniel is saying do this. There is no right or wrong answer here. You can come up with a solution. All you need to do is prove this is eventually a multiple of 6. You have to get 6 common somehow. Now don't do some sorcery. I need a proof, okay? Logical proof following through. So you're almost there. But I need 6K. Shlok, you're very quiet today. What happened?
You will get 3 multiple of 3 and then again the multiple of 3 can do it multiple of 6. Because the
No,
multiple of 3 is the multiple of 6.
but 3 is a multiple of 3. It's not a multiple of 6. 15 is a multiple of 3. It's not a multiple of 6. No, you want multiple of 6, okay? But come up, Ashen. You're very quiet today.
we just add n to the other side and we just plug it into n.
Okay, and would that help me?
That would make it a lot easier. Find out it's visible by
So Ashen is saying use equation 1, which is 9n minus 3n. Okay, but you see there are many ways. So he's saying do this 6k plus 3 and then plug it in here. 3n, you mean? Okay. 6k plus 3n times 9 minus 3n times 3.
and then you just
Oh, I see it. I see it. Okay. Yeah, so that is working out, right? 6k times 9 plus 3n times 9 minus 3n times 3. I can take 3n common. This is 9 minus 3, which is 6. So that's, see, this stick to a technique that works for most questions of this form, or stick to Daniel's technique or Shlok's technique, but have a strategy in mind, okay? There is no right or wrong answer. Eventually, you will get a multiple of 6. Read the solution on the PDF files, okay? But this is it. This is all I had to cover for induction. Read my lecture notes, okay? And this video will be posted. I wish you all the best. And